And finally, reservoir engineering insight number 3, unrealized potential. So this is where we start to use the subsurface knowledge and the reservoir engineering knowledge to try and uncover some opportunities. This is what a lot of the private equity guys and the investment people we spoke to were the most interested in. How do we use reservoir insight to, to find underperforming assets? That's probably the easier question to answer. In fact, I've done a lot of that throughout my career, so I'm going to just show you a couple of very basic examples of how we do that. But more importantly, and much more challenging to answer, is how do we relate value created in the reservoir to shareholder and market value? There's not always a clear relationship between that, right? So how can I use my insight as a reservoir engineer really to show market value? There's a fuzzy boundary between those two things. It's not always clear how to do that. So I'll give you my thoughts on that. I don't have the silver bullet, but I have some ideas about how we might address that. So this example is what I call low-hanging fruit. And I've had this example for years and years and years. This is probably 15 years old at this point. But it's my favorite gas production example for showing unrealized potential. Because what you're looking at here is gas production, and it goes into decline. But as you can see, the flowing pressure profile is continually climbing. This is a classic case of a well being backed out of a pipeline. So we have insufficient surface facilities to accommodate this well, and it is essentially being backed out of the system. This is the lowest hanging fruit that you can find, right? If you've got a field full of wells like this, that is investment opportunity like you can't even believe, right? That's the easiest problem to fix. That's going to give you the highest rate on return of any capital that you could spend. The drop in production rate, I didn't show all the RTA plots that go with this, but we can use RTA to analyze this and find out that our original gas in place is actually 24 BCF. Our recoverable gas is 18 BCF. If we do a straight decline curve analysis on this, this well is only going to make 3 BCF under current conditions. So there's a huge potential uplift here to solving this problem, and it's a relatively easy problem to solve. Here's another example. This one's a little more difficult to spot and potentially more difficult to fix, but probably more common, right? Every well that's ever been drilled, as it produces, will experience some sort of productivity loss, right? A loss in its productivity index. So gas well number 1, gas well number 2, which one is underperforming? And I presented these examples at another talk I did last year. And I'm reusing the material here because I like this example. When you look at the data, you can't really tell, right? If you used a 30-day peak rate or a 90-day peak rate, still you wouldn't get a clear answer. You might get, and I'm not showing the cumes, but these wells' production profiles over the first few months are roughly the same. Okay? You can't really tell which one's underperforming. But when we use our handy RTA diagnostic plot, linear flow plot, again, remember, flatter is better. We're not necessarily comparing which is the better well in this example, but what we're showing is a key thing here in well number 2. There are actually 2 distinct trends. If we go back to the data, we don't really necessarily see that just with the raw production data. But when we lay it out on an RTA diagnostic plot that includes the impact of the flowing pressures, it becomes very clear that well number 2 has a reduction in productivity. That's a line with a certain slope there, and then once the well starts to drop its productivity, it has a steeper slope. That's all the data after 2 months. That couldn't be more clear, right? So we know that there's a productivity loss there. And there's the baseline performance expectation. So, and I'm not going to belabor this, but we have a sort of a matrix of diagnostics that we use to identify common wellbore problems. We do this in a lot of our reservoir studies that we do when we look at existing production. And these problems can be sort of categorized or binned according to whether they're surface, wellbore, or completion reservoir. And there's a definite progression in terms of how easy or difficult it is to diagnose and resolve these issues as you move down towards the subsurface. In other words, surface issues are much easier to fix than reservoir issues, right? Reservoir issues are usually more expensive. There's a lot more uncertainty in whether you're going to get a good result. They're riskier. They cost more capital. If they work, they can often, be very rewarding. But my thought has always been find the surface and maybe wellbore issues first. And there's lots of different issues that can come up. For surface, we already talked about insufficient pipeline capacity. When you get into the wellbore, mechanical blockage, unmilled ball seats, for example, blockages in the wellbore. I have examples that show that as well. If I had more time, I'd get into all of that. But basically, this is sort of a diagnostic matrix that we can use to both identify, shows the symptoms, how we identify those symptoms, and then potentially how we resolve those issues. What are the steps that we take to do that? So how do we harness all of this information and make it valuable from a, say, investment perspective? A lot of the existing production stuff isn't as interesting to investors and private equity people. They're more interested in the new stuff that's going to be drilled later. But certainly as petroleum engineers working in oil and gas companies, we're really interested in this stuff, right? Especially in a low price environment. We want to be able to solve, find the low-hanging fruit that requires little risk, and we can get a good result very quickly. So we're going to find an asset where wells are underperforming against the reservoir due to surface or wellbore issues. One of the best examples I ever saw of this was a tight gas field that had multiple stacked sands, and the tubing in the original completion, the tubing was set basically at the top of the first sand, and there was about 200 feet or 250 feet of limited entry perforations, multiple fracs, and every single well was completed that way. So over time, what happened is you're building up this liquid back pressure against the lower zones, and they weren't contributing at all. So the operator went in and lowered the tubing about 100 feet on every single well and got an uplift of about 30%, just like that, just for lowering the tubing. Let's talk a little bit about translating reservoir value into market value. This is more of a discussion. There's no real sort of hard results that come out of this, but I do think there's some interesting sort of topics for discussion here. So who are the most successful oil companies? Why are they successful? These are questions I ask myself. And more importantly, how are value and success measured, right? How do we actually measure it? And we talked about IP30 already. IP30 is a measurement that's very commonly used. And I find that some companies are starting to move away from that, and that makes me happy. I like to see companies using a longer term approach for measuring initial production. 90 days certainly is better than 30 days, still not great, but if you can go to, say, a 365-day IP. So when I'm looking at investor material, I look for this, like people talking about this rather than IP30. That gets my attention. Other measures of value, time to pay out, cash flow, especially in a suppressed product price environment, this is really important, right? How quickly can I get return on capital? How quickly can I pay out my investment? NPV, IRR, these are more long-term metrics, right? So, NPV doesn't necessarily have a time frame attached to it. It could be more of a long-term investment. This is one that a lot of people maybe don't think as much about, repeatability and scalability with low risk, right? I can be successful in one play, but can I repeat that somewhere else? And how scalable is that strategy? So those are some sort of general ideas. But I'm going to make the statement, optimized reservoir management isn't always rewarded in the market. But my opinion is that it will almost always provide the best long-term NPV for the asset. And I'm going to show you some examples of why I think that's the case. So let's talk, first of all, a little bit about strategies that oil and gas companies use. And there's obviously as many different strategies as there are companies. So this makes it really difficult to compare apples to apples when you're looking at, what does company X versus company Y do. But I tried to sort of make this a little bit simpler and talk about short-term strategies versus long-term strategies. So these are the sorts of things that you see a lot in the market right now and at other times as well, especially with smaller companies that are just starting up. Again, it's all about maximizing IP. minimizing drilling completion cost, find the sweet spot, pursue aggressive completion and treatment designs. One of the reasons why companies are doing this right now is because the cost of those frac jobs have come down so much, right? We can really be aggressive in those. And we're seeing those, the statistics on that going up every year that goes by. And value is often measured using time to pay out in these sorts of scenarios, right? In these sorts of strategies. And value is also measured well by well, right? We're looking at everything well by well. That's why I'm calling it a short-term strategy. There isn't a 20-year outlook or a 30-year outlook on this sort of strategy. It's more like, we're looking at a 2-year payout or a 3-year payout at the most. On the other hand, we have long-term strategies. The idea here is to maximize the ultimate recovery of the entire asset. That's very different than looking at well by well. Focus on integration of disciplines, focus on understanding the reservoir. In order to do this, you have to collect more data. You have to understand the value of information. Focus on controlled optimization. And value is measured more using NPV IRR in these sorts of scenarios. And value is measured at the asset level rather than at the well level. So I'm not going to say that one of these is better than the other, but they're different strategies, right? And it took, as a reservoir engineer, I didn't really think this way for a long time, but when we started talking to the private equity guys, I started to think much more in these terms. When you're doing a project or trying to optimize something or trying to even characterize a reservoir, how is that value being measured? Is it being measured this way or is it being measured this way? And they're very, very different things. In fact, they're mutually exclusive strategies. Often what you do here is not good for what you get here, and what you do here would not be good for what you get here. So if you're a petroleum engineer working in a company, make sure you understand how the value is being measured. That's critical. Here's the implications. Short-term strategies are required. If you're a startup company, you've got to use a short-term strategy. That's how you grow. That's how you get yourself on the map. But maybe short-term strategies are not easily repeatable or scalable. That's the other point. It's difficult to really take what you did here and make it work here and here and here and here. The analogy I use that goes with this is like if you're an investor and you're a day trader on the stock market, you can do some successful trades, but it's really, really hard to consistently do that day in, day out, right? Whereas if you're a long-term investor, it's a different story, right? So short-term strategies, because they're short-term, you got to keep doing them. You got to keep repeating them. And how many times can you really keep repeating these things? It's difficult to do. Companies with successful short-term strategies are often overvalued by the stock market. That's my opinion. And I don't know if you agree with that or not, but that's an interesting topic for discussion. Long-term strategies are boring, often go unnoticed. Operators employing long-term strategies are usually successful across multiple plays and basins. Now here's kind of my key statement. I'm going to say small companies with successful long-term strategies are often undervalued by the stock market. Large companies, the Shells, the Exxon Mobils, they're very, very, there's a lot of investor attention on them. There's a lot of research. So everything's, there's a lot of knowledge there already. They may be undervalued or overvalued. So I won't make any statements about those. I won't get into that. But I will say that if it's a small company that really takes a long-term look, it will tend to be undervalued. And the reason why is because they're not maximizing their IP30. They're not looking at time to pay out. They're not doing all these things that really capture the investment community and the market's attention. And the other point I'll make is every single one of the world's top 25 oil companies by profit and market cap employs long-term strategies. They have to. If they didn't, they wouldn't be here, right? That's the only way that they're going to get to where they go. So again, both of these strategies are important to be used at different times, but understanding how what you're doing relates to that, I think, is really critical. So I'm going to give you a couple of examples. The example I'm going to talk about here, and I'm not going to mention any names. This is a real case that we worked on, and it's what I consider completely opposing oil field strategies. And again, I'm not making a statement one is better than the other, but I'm going to say they're very, very different strategies. And if you were an engineer working in one of these companies and you didn't know what the strategy was, you could be the best reservoir engineer, but you're going to not necessarily know how the value is being measured. So it's a really sort of interesting thought experiment to try and understand this. So operator A in this part of the Montney minimizes drilling and completion costs by avoiding directional drilling and using uncemented liners. So it's a low cost, so check box A for short-term strategy. Drills toe up through multiple benches to maximize total reservoir exposure, contributes to, of course, that's going to contribute to a high initial productivity and better liquids recovery because it's toe up. So these are good strategies, right? Large proppant volumes per stage maximize the frac area, and connection to the reservoir contributes to the high IP. And drilling through the multiple benches in this area of the Montney is going to give maximum exposure to all these different zones, right? This is a highly stratified, complex geology, and going through all of those zones is going to give us the best chance of getting a good well, right, and access to as much reservoir rock as we can. Flow back, the wells are flowed back unchoked to maximize IP and minimize payout time. Again, another good strategy for making sure you've got cash flow, making sure you're recovering your capital costs as quickly as possible. Operator B operates in adjacent, very, very close to the same area. There's not that much difference in the geology. There's some. I'm not going to say there's none, but they're operating in a very similar part of the Montney. They spend more on drilling and completion. Okay? They drill their wells directionally. They stay in zone. So the various different benches of the Montney, they're drilling their wells to stay within the zone. They're also using cemented liners with pinpoint completion technology. One of the reasons they're doing that is because they want to have, at the end of the day, they want to have a lot of stages in their well, 100 stages, 150 stages. They want high stage density, which can't necessarily be achieved with an open hole completion. The high stage density and lower proppant volumes per stage, so the treatment per stage is smaller, but this is designed specifically to maximize recovery efficiency in that zone and along the lateral. But the consequence of that is that you're not going to necessarily get a great IP out of that well, right? You're going to get good consistent performance over long term, but you're not necessarily going to get the best IP. And the wells are flowed back on choke to manage liquids recovery and maintain reservoir pressure above dew point. This is a liquids-rich area, so that's critical as well. For long-term liquids recovery, you don't necessarily want to flow back to an open choke. You might drop below dew point and leave a lot of those condensates and liquids behind. So very different strategies. Let's talk about advantages and drawbacks of these strategies. So the operator A short-term strategy, they're getting faster payout on their capital. They're also getting market recognition because they're getting the IPs, they're showing low cost, they're getting good return on capital. So this is great. Let's talk about the drawbacks. Maybe this is an inflammatory to say inflated, but this is a real possibility. If you're in the spotlight, it's probably going to be overvalued. Risk of loss of repeatability. How long can they keep drilling wells that way? You're potentially going to lose future drilling inventory if you have those 4 benches or whatever it is in the Montney and you're blasting through all of them. If you've got unlimited room to run, you can keep drilling wells like that all day. But if eventually you need to start infill drilling and downspacing, there's going to be a robbing Peter to pay or robbing PDP to pay PUD issue happening there as well. Let's talk about long-term strategy operator B. Understated shareholder value. I think that stands to reason because they're not necessarily going to get the best IPs. They're not necessarily getting the payout as quickly because they're spending a little bit more on the completion and drilling up front. However, they have a plan that's repeatable and scalable, and it's better for long-term performance and profitability. So this approach will actually have a better NPV, and I've crunched all the numbers, right? It'll have a better NPV. But it depends what sort of outlook you're going to take, a long-term or a short-term. Slower payout on deployed capital, of course, and unimpressive initial production compared to this one here. So, that's an example where I've got personal experience in looking at the data. I'm sure there's lots of other examples of different strategies. And sort of to wrap up some final thoughts, reservoir engineering insight can be useful in the investment community. Really, that goes both ways. As petroleum engineers working in our oil companies, we get value in understanding that the bridge that connects us with the people that are holding the shares and really where the money is coming from, right? If we understand how that value is being measured, we can do our jobs better. So I think that's a big win. But it also helps, of course, the other way around. If the investment folks can understand what the engineers are doing and use that insight in making their decisions, they're going to make more informed decisions as well. So specifically, as I've shown today, it can help identify red flags, the PDP issue, the peak rate fallacy, false causality, and there's a million other things too. I haven't talked about all of them. I just picked some of the more interesting ones. It helps us filter out the noise, focus on what's important, helps identify underperforming assets, helps identify undervalued or overvalued companies. And I'm saying helps because you obviously need to look at a lot of other different things, right? This is just one component, and that's the subsurface. So here's my final thoughts. Successful operators and management teams are always very clear on how they measure value, right? If you're working in a company and you don't know how that company is measuring value, you're off to a bad start. You could be the best engineer in the world, doing the best reservoir management, but if you don't know how your value is being measured, that's a big problem. Perhaps even more importantly, if you're going to be successful and be around for a while, you've got to be able to execute repeatable and scalable development strategies. Companies that are successful in multiple different plays and are able to make it work, and they're always in the top three, you never wonder why those companies are so successful. They don't have a silver bullet, but they're able to consistently perform to a level of competence across all the disciplines in the value chain, right? So you're only going to be as good as your weakest link. So you don't have to be the best at everything, but if you're able to maintain that level of consistency across all of those competencies, G&G, land, completion, drilling, reservoir, all of those ideas or all of those parameters are going to contribute to an overall good result.